Electronic cruise control is such a common feature on today's Buicks that the system is probably taken for granted, at least until a problem arises. Now, it's true the basic operating principles of cruise control haven't really changed a great deal over the years, but there are differences among the cruise control systems used in certain models. And these differences are significant enough that if you haven't worked on a particular system before, you could find a surprise or two. In this program, we'll review the cruise control systems used on current Buick cars, how they operate, and how to go about diagnosing problems. First, let's quickly run through the items that make up the cruise system. We'll start here under the hood. Probably the most recognizable component associated with cruise control is the servo unit. The servo is basically a small vacuum chamber with a flexible diaphragm on front. The diaphragm assembly is referred to as the vacuum actuator. Two hoses are connected to ports on the servo chamber. One port is for the internal vacuum supply valve, and the other is the vacuum release port. An internal vent valve also vents the servo chamber to atmosphere through a third port. The vacuum valve and vent valve are solenoid operated. The solenoids are electronically controlled by the cruise system. With the cruise system off, the vacuum valve remains closed. The vent valve is normally open. The vacuum valve hose is routed to a vacuum supply tank, which accumulates sufficient engine manifold vacuum to operate the servo even when the engine is under load. When the servo vacuum valve is opened and the vent valve closed, suction from the vacuum tank pulls the actuator diaphragm inward. The distance the actuator moves is determined by how long the vacuum valve is held open. The front of the servo actuator is connected by cable to the throttle lever. When the actuator pulls inward, the linkage pulls the throttle lever open to maintain the speed selected by the driver. By opening and closing the vacuum and vent valves, the cruise controller can move the actuator in and out. In this way, it can also raise and lower vehicle speed. When the actual speed of the car varies by more than 1/4 of a mile per hour, above or below the selected cruise speed, the controller pulses the valves open and closed to adjust the throttle and maintain the selected speed. The hose from the vacuum release port is routed inside the car to a normally closed vacuum release valve mounted on the brake pedal bracket. The release valve is positioned so that when the brake pedal is pressed, the valve opens and outside air enters the servo chamber to quickly release the throttle. The mode control switches that operate cruise control are located on the multifunction lever here on the steering column. When any mode switch is activated, selecting a function, a signal is sent to an electronic cruise system controller. The controller is, you might say, the brain of the system. Now let's look at what happens inside the cruise system during normal operation. When the set signal is received, the controller closes the servo vent valve and opens the vacuum valve. When the car's speed stabilizes at the set speed, the controller uses both servo valves to trap the actuator at the correct setting. The controller maintains the selected speed until further signals are received, such as from the brake pedal or the ignition is turned off. When the controller detects that the car is slowing down due to an uphill grade or whatever, it pulses open the vacuum valve to open the throttle just enough to maintain the set speed. The controller pulses the vent valve in the same way to reduce speed when the car is traveling downhill. 3 different types of system controllers are featured on Buick car lines. On the most widely used version, the controller is a separate module. The cruise control module is electrically connected to the rest of the system by a multi-terminal harness connector. Through these terminals, the module receives signals from the control switches and sensors. One important input is from the engine control module, the vehicle speed signal. On all cars except the estate wagon, the vehicle speed sensor is a permanent magnet or PM generator located in the transmission governor assembly. The sensor consists of a permanent magnet positioned beside a coil. The ends of the coil winding are attached to the sensor connector. The governor shaft is gear-driven by the transmission. A rotor at the top of the shaft rotates within the permanent magnet field. As the rotor teeth pass in front of the magnet, pulses of electrical current are generated in the coil. This signal is sent to the engine control module, where it is converted to a square wave signal. The cruise control module calculates road speed based on the frequency of pulses received from the ECM. The cruise controller is calibrated to calculate miles per hour based on a frequency of 2,000 pulses per mile. On the Buick estate wagon, an optical sensor in the speedometer assembly produces the vehicle's speed signal. This signal is routed to a cruise control module through a separate buffer module. The sensor bounces an infrared light beam off a reflective disc that turns with the speedometer cable. As the disc rotates, pulses of light are reflected to a photocell in the sensor. The frequency of the light pulses increases with vehicle speed. Again, the system is calibrated so that 2,000 pulses represent 1 mile traveled. In most cases, the cruise control module also receives a feedback signal from the servo unit. The vacuum actuator in the servo has a steel core that travels within a coil winding. The cruise control module sends an 8-volt current through the coil. As the actuator's steel core moves within the coil winding, the inductance of the coil is changed. So, by monitoring the voltage induced by the coil, the cruise control module can determine the position of the servo actuator. Another important input to the control module comes from the cruise control brake switch. Located on the same bracket as the vacuum release valve, this switch electrically disengages the cruise system when the brake pedal is pressed. I mentioned earlier, 3 types of system controllers are used on Buick cars. We've looked at the most widely used type with a separate cruise control module. On Riviera and Reatta, cruise control is a function of the body computer module. In cruise operation, the BCM performs all of the functions of the cruise control module. Input signals are received from the control switches, the brake switch, and the servo position sensor. The vehicle speed sensor signal is received through the ECM-BCM data line. The BCM also has the ability to disengage cruise control when incorrect operating conditions are monitored through the data line. If, for example, the park neutral switch input to the engine control module indicates that the car is shifted out of drive during cruise operation, the BCM disengages cruise control. With Riviera and Reatta, the BCM is the central controller for onboard diagnostic functions. So, as we'll see a little later, the diagnostics can be used to monitor and test parts of the cruise system. A third type of control system is used only on some Skylark and Century models. When equipped with the 2.5-liter L4 engine, cruise control is operated directly from the engine control module. As with the body control module system, the ECM controls the servo in response to signals from the mode control switches and the brake switch. However, the signal from the servo position sensor is not used. Instead, the ECM uses the signal from the throttle position sensor to determine the position of the servo vacuum actuator. Also, since the controller is the ECM, the speed signal is obtained directly from the vehicle speed sensor. Like the BCM, the ECM can interrupt cruise control operation whenever conditions are sensed that could adversely affect cruise operation. We'll discuss this feature in more detail a little later. But for now, let's look at how to go about diagnosing cruise system complaints. In general, cruise control complaints fall into three categories.
First, the entire cruise system may be inoperative. That is, none of the functions work. Second, part or parts of the system may be inoperative. The third situation is where the system operates, but with undesirable symptoms. Undesirable symptoms associated with cruise control are speed surges that occur only when cruise is engaged, excessive speed loss on hills, and cruise speed that remains higher or lower than the set speed.
Also, of course, the problem may be intermittent. Let's begin our diagnosis by assuming we have a case where the system is totally inoperative. As we've seen, cruise control incorporates mechanical components, a vacuum system, and electronic controls. The cause of a complaint may originate in any of these areas. We start our diagnosis by looking for any obvious mechanical and vacuum problems. A thorough physical check is very important. A loose or damaged vacuum hose connection is all it takes to disable the system. Check the vacuum hoses for good connections at the servo, at the supply tank, and at the engine vacuum source. Examine each of the hoses for leaks, kinks, or other restrictions. If a check valve is used, verify that the connections are good and that the valve isn't stuck open or closed. Check that the throttle and servo linkages operate freely and smoothly. Check for excessive slack in the linkage between the servo and the throttle lever. The linkage should be adjusted so that the throttle opens easily when the servo actuator diaphragm pulls in. The throttle must also close completely when the diaphragm is released. Check the harness connections at the servo unit for damage or corrosion on the pins. After thoroughly checking under the hood, don't forget to check the vacuum release valve at the brake pedal. After any obvious vacuum or mechanical problems have been eliminated, the next step is to test the electrical operation of the system. But before we move on to electrical diagnosis, let's look again at the possible complaints. If the complaint involves only part of the system or an undesirable symptom, a system check should be performed. The system check allows you to verify the full extent of the problem. With cruise control, the only really effective system check is a road test. So let's run through the procedure. Accelerate the car to more than 25 miles per hour and turn the cruise switch on to activate the system. After a couple of seconds, press and release the Set Coast button when the desired cruise speed is indicated on the speedometer. The set cruise speed is now stored in controller memory. When first turned on, the system has a built-in 2-second delay feature. This gives the controller ample time to correctly interpret vehicle speed. The delay feature also prevents an uncalled-for cruise speed being stored if the set button is accidentally pressed as the system is turned on. With cruise on and operating, press and hold the Set Coast button. As long as the button is held in, the car should coast slower. The car should maintain the new speed when the button is released. Remember, if car speed is allowed to drop below 25 miles per hour, the cruise system automatically disengages. Next, slide the cruise switch to the resume accelerate position and hold. The car should continue to accelerate while the switch is held. When the switch is released, the system should maintain the new higher speed setting. Tap on the brake pedal to check that cruise disengages immediately when the brake is applied. Slide the cruise switch momentarily to the resume accelerate position. The car should now accelerate to the previously set cruise speed. The accelerator should still function normally with cruise engaged. Test this by accelerating briefly, then releasing the accelerator. The car should return to the set cruise speed when the pedal is released. Next, tap the cruise switch to the resume accelerate position. Speed should increase by 1 mile an hour each time the tap up function is used, up to 10 taps. The set coast switch is used in a similar manner to tap down speed in 1 mile an hour intervals. Lastly, turn the cruise switch off and check that the system disengages. A system check table is included in the know-how reference manual. You can use the table as a guide during the road test. The reference manual also contains a cruise control symptoms guide. The guide provides a list of the items that should be checked for each type of condition. From this point, the troubleshooting procedure used depends on the type of control system the car is equipped with. On cars with a separate cruise control module, start with a circuit isolation test using one of the approved quick checker tools. The checker tool is attached directly to the harness connector for the cruise control module. With the quick checker connected, set the mode control switches according to the tool instructions. Then observe the indicator lamps on the tool for the proper responses. When any lamp shows an incorrect response, an instruction table directs you to the appropriate follow-up tests for that part of the system. You'll find a copy of a quick checker test table in the Know-How Cruise Control Manual. Follow-up tests generally consist of using a DVOM to measure for voltage, continuity, or resistance between specific terminals at the mode switches, the control module, and the servo connector. For example, if the vent lamp doesn't light with the cruise switch on, the table will instruct you to check for an open in the solenoid ground wire that runs from terminal C on the harness connector. If the wire is okay, the next step is to disconnect the servo connector and measure solenoid coil resistance between terminal A and C on the servo. If measured resistance falls outside of the correct limits, the vent valve solenoid is faulty, in which case the servo unit should be replaced. If a quick checker tool is unavailable, a similar isolation test can be performed using a DVOM alone. The procedure involves measuring for the correct values at each terminal of the control module harness connector. To do this, first check for a good ground at terminal J of the connector. Then operate the cruise control switches and measure voltage at the appropriate terminals, using J as the ground. If any measurements are found to be incorrect, check the wiring to that terminal. If the wiring is okay, follow the instructions under the DVOM isolation test procedures in the Know-How Reference Manual with this program. Now let's look briefly at the other two systems. With Riviera and Reatta, the first step is to check the onboard diagnostics system for stored trouble codes. To enter diagnostics, press the off and temp up switches on the climate control panel. When diagnostics are activated, the odometer display in the instrument panel shows all the stored codes beginning with ECM codes. BCM codes are displayed next, followed by instrument panel and inflatable restraint system codes. Cruise control is a function of the BCM. BCM trouble codes are prefixed with the letter B. The suffix H indicates a history code, meaning the code was stored before the ignition was last turned on. A suffix C for current appears to indicate when a condition is actively being sensed. When a code is present, refer to Section 8D of the Riviera Reatta Service Manual. The manual provides a full description of the code, a circuit diagram, and a trouble tree chart for diagnosis and repair. For example, code B673 indicates a fault in the vacuum solenoid circuit. To test the circuit, you can use the onboard diagnostics to select BCM output test B002. When this output test is activated, The BCM cycles the vacuum valve solenoid every 3 seconds. The solenoid can be heard clicking as it cycles. If it doesn't cycle, the next step is to attach a test light at the connector and check that power is reaching the terminals. When diagnosing ECM control systems on Century and Skylark with 2.5-liter engines, the first step is to check for trouble codes. Unlike the BCM, the ECM does not record specific trouble codes for the cruise system. But cruise operation may be affected by the presence of other related conditions. The ECM can inhibit cruise operation if it detects a fault with the throttle position sensor codes 21 or 22. The same is true if a vehicle speed sensor fault code 24 is detected. So if these or any other codes are present, the cause should be found and corrected before continuing with cruise diagnosis. When diagnosing an ECM control cruise system, a CAMS terminal or a Tech 1 scan tool can be used to perform isolation tests for the control switch functions. When a switch is activated, the terminal indicates that the input is being received by the ECM. If it isn't, then the switch wiring should be checked, and if necessary, the switch should be replaced. You can also use the CAMS VSM or the Tech 1 to monitor the vehicle speed sensor signal while the car is being driven. Step-by-step instructions for the scan tool test procedure are given in the Century and Skylark service manuals and the know-how manual. The ECM control system can also be tested by using a DVOM to test for correct signals at the ECM harness connector in much the same way you would test at the cruise module connector. Again, full step-by-step instructions for the DVOM test procedure are given in the Century and Skylark service manuals. The 1991 Park Avenue has a cruise system similar to the ECM control type. We'll be dealing with this as well as other features of the new Park Avenue in upcoming know-how programs. There were quite a few requests for a know-how program on cruise control systems. I hope this overview answers any of the questions you might have had. And remember, if there's any subject you'd like to see in future programs, the folks at Know-How Headquarters are always glad to hear your suggestions.